the first problem here is it's a volume. You got to find the volume of the larger minus the volume of the smaller. Can you tell me what the volume of the larger would be? That big
12
shape.
times 6 times 4
Yep. And then you're subtracting out the cube, which is 4
times 4 times 4.
Yeah.
I get 224.
Okay. And what are the units of that?
That is meters cubed.
Good. All right. So the next one is again, kind of we've done this one before. So you got to find the volume of the cube plus the volume of the pyramid. So the volume of the cube is 6 times 6 times 6. The volume of the pyramid is 1/3 the area of the base. What's the base?
The base is 6.
What's 6 times 6? It's
6 times 6.
it's a square, and then the height is
8.
8. So go ahead and calculate that, please.
$312 feet cubed.
312 feet cubed. Perfect. All right. You'll probably need that calculator for the irregular polygon.
Okay.
So just kind of have that handy in case we need it. All right, so I've got a sphere coming up next.
Okay.
So a sphere, volume of a sphere is 4/3 pi r cubed. And like we discussed last time, it says in terms of pi. So you just leave the pi out when you're doing the calculation.
$972 pi.
Okay. And that's centimeters cubed. Now, the surface area is 4 pi r squared. What is the surface area?
$324 pi.
Yeah.
Oh, centimeters cubed.
Yeah. Okay, I'm gonna just snip something in here. Go ahead and take a look. I'll be right back.
Okay.
Okay, what does this fold up into?
So this is a rectangular pyramid.
Rectangular pyramid. Good. Yeah, all the right words there on that one. It's good. So next question here. We're kind of moving away from the ones that are visual. We're just moving to the ones where we got to make a drawing each time. So it says identify the volume of a cube with length edge 9. So there's the front face. 9, 9, and 9. What's the volume here?
9 times 9 times 9.
Okay.
729.
729. Good.
Meters cubed.
Perfect. All right. So the next one here is this isometric thing here. So basically we start with the isometric view here.
Yes, that is correct.
That looks correct.
Is correct. The top is not correct.
Side is also not correct. Yeah, good. Yeah.
Well, actually, that is correct because the side is.
Ooh, well, You're right. That is correct.
Because we're looking at this side and that's the front, so
Yeah, I think words like front, back, left, right would be better here. Good, but
yes.
good point there. All right, do the orth no, yes, no, yes. All right, perfect. All right, so here, I know this is not easy because you can't touch it, but we've got to identify the number of vertices, edges, and faces. So go ahead and just, pick one or the other and tell me what you see, okay?
Okay. I see 6 vertices.
Okay, but there's 1, 2, 3, 4, 5, 6. That has them all. Okay, good. How about edges or faces?
So there are 5 faces.
Let's count 1, 2, 3. Yep, there's 5 faces. And so the edges are a little bit tougher. Maybe 1, 2, 2, 3, 4, 5, 6, 7, 8,
9.
9. Yeah, and that does satisfy Euler's thing here. Vertices 6, edges 9. There we go. Perfect. Okay. What's the next one here we can do? I'm just going to go back through the list again. Okay, here is another volume problem, but it requires you to draw it here. So it's a hexagonal pyramid. So that means the base is a hexagon,
And it's just pyramids.
right? So the volume here is 1/3 the area of the base. So you've got to go and use one of those calculators to find the area of a hexagon. Get that number and then multiply it by 10. In a previous chapter, we spent a lot of time finding the area of the regular polygon. It was a formula like S over.
So for the
E.
area, I get 166.3.
Okay. So then for the volume, you got to do 1/3 of that times the height, which is 10. But do you remember that formula we did? It was like sine or I think it was tangent of like 180 over n. Do you remember that?
I believe so.
Okay, that's all that calculator is doing. It's not doing anything we haven't already done, is the point.
554.3.
Inches what? What are the units here? Inches?
Oh, inches cubed.
Okay. So you got to give a complete answer. All right, so next question here, I want you to identify the value of K first. Let me snip it in. What is the value of K here?
Cubed. Oh, the value of K is 30. Oh,
What does that word mean?
Divided.
Okay, so that means K is 1/3.
Yes.
Okay, so volume, what do we do to K?
We cube it.
Cube it. So we have to cube 1 and cube 3. What does that become?
1/27.
Yes. Do you enjoy doing the calculator parts of this? Or do you feel like
They're interesting.
Do you feel like it's tedious? Like you just write the formula down and put the.
Yes.
Okay, so here's a cylinder, the can.
Mhm.
It's got a diameter of 22. The diameter is useless to us though.
Don't we want the radius?
What is the radius?
The radius is 11.
11 what?
11 centimeters.
Okay, so the volume of a cylinder is pi r squared times h. And it says round to the nearest 10th. So you know you're going to put that pi into the calculation.
3,421.2.
Good. All right, so take a look at this picture here. The butter stick. What kind of shape would you name this?
Um,
And
uh,
assume that this is the base right here. This is the base.
a rectangle.
A rectangle is 2 dimensions. So what's the 3-dimensional space?
Oh, rectangular prism.
Perfect. And the vertices are all the letters, right? L, M, N,
That's 8.
O. We don't have to count them. P, Q, R, S, but they're all the vertices. Do you agree with that?
Yes.
Okay. Now the base is a rectangle.
Mhm.
Okay. The base is a rectangle L, M, Q, R, and N, O, P, S. Do you see that?
So it's the top and the bottom.
Well, actually, it could be the top or the bottom. Yeah, or the side. I don't really know. I guess it's L, M, L.
Because I thought that, well, since it's Q, R, P, and S, because that's where it's sitting, they're not really specific on like
Yeah,
this is the base, this is the top, these are the sides.
right. Okay, next question. Okay, it says identify the volume of a cone with radius 6. So the radius is 6 and the height is 11. The volume of a cone, it's like a pyramid. It's 1/3 the area of the base, but the area of the base is pi r squared times the height. This time it doesn't say in terms of pi. It just wants a decimal approximation, so round to 1 decimal
Okay.
place.
$414.7.
7 what? Like,
Oh, 7 meters cubed.
okay, you got to give the dimensions. Really important. Really important. Okay. So we're moving through. We got that one, got that one. I'm just doing one more pass here to see what we got here. So here we go. Here's another one of those K problems where you determine the value of K. So read this carefully and tell me just the value of K here. K is the change, whether it's multiplying or dividing.
K is 1/2.
Okay, I agree. And we care about area. So what do you do to K?
You just square it.
Okay, so what is 1/2 squared?
That is 1/4.
1/4. Perfect. Okay. All right. So we did these problems. We did I think an entire lesson on distance and midpoint here.
Okay.
So the midpoint is the first thing. The first thing you want to find. The midpoint is x1 plus x2 divided by 2. It's always the average. y1 plus y2 divided by 2. z1 plus z2 divided by 2. So could you go ahead and find the midpoint for me of those 2
Yes.
points?
Okay, I got 6, 6.5, and 4.
Okay, very good. Now the distance is a little bit harder. You have to take x2 and subtract x1, square it, plus y2 minus y1, squared plus z2 minus z1 squared, and then take the square root. Okay, so let me know if you need to scroll up here. Actually, let me just snip in the points again in case you need them. But this is rounded to 1 decimal place.
Okay.
So there's your points. So I just want the final, kind of the final answer on that, please.
Okay.
Definitely need a calculator for that one.
Okay, I get 8.5 as my final answer.
Okay, very good. That looks good to me. Okay, we're doing really good here. Let's do one more question, then we'll just take like a 1-minute break.
Okay.
This one is, okay, this question. So it says find the length of the diagonal of a prism. So we did these problems where I said, okay, let's draw the base 7 and 6 again, not to scale. And then this is 12 up here.
Mhm.
And you have to first find the diagonal here, which is C, and this is a right triangle. Okay. So if you recall, C squared equals 6 squared plus 7 squared. C is the square root of 6 squared plus 7 squared.
Which is
Okay.
36 plus 49.
So it's the square root of 85.
Yes.
And then to find this diagonal here, which is the one they're asking about, this is another right triangle.
Mhm.
So I'll call this D. D squared equals C squared plus 12 squared. Your C is the square root of 85.
Okay.
So it's 85 plus 12 squared. And then you take the square root of that.
So 85 plus 144.
Square root of that, and then round to the nearest 10th.
That is 15.1.
Okay, now what are the units? And it's a length.
So that's centimeters.
Good. Okay, so just take a 1-minute break here.
Okay.
And
How
just
many
check.
questions do we have left?
I'm gonna count. I'll let you
Okay.
know. All right, so it looks like we just have 4 questions left, and they're all lateral area and surface area, so they're potentially pretty long, depending on if we have to find both. So the first thing is they tell you that the base here is a rectangle.
Mhm.
And these are kind of the frustrating ones to me, but this is the base. The base is 12 by 10, and it's not included in the lateral area. So what is included is this front face. So the lateral area is this 12 by 16,
Mhm.
this front face, but there's two of them, plus the side, the left and the right side, which
Yeah.
is 10 times 16 times 2.
2. $704
704 what?
centimeters
It's an area.
squared.
704 centimeters squared. Good. Now the surface area you add to it. So the surface area is the lateral area, which is 704, plus you now have the bottom, which is 12 by 10
Hmm.
times 2, because you got two of those.
I get 944 centimeters squared.
Very good. As I mentioned, almost all the rest of these that we're going to look at are lateral and surface area problems. So let me snip the next one in. So this is a hexagonal prism. The problem is when I draw it as a hexagonal prism like this. Let me see, what am I doing here? This is the base, so it's not included in the calculation of the
So
lateral
this
area.
is standing up, not.
Right. So to find the lateral area, it's just these rectangles,
Mhm.
which is 4 by 7, and then there's 6 of them.
Okay.
Yeah, and exactly, it's sitting on that, but it's hard to draw when it's sitting on that. You end up having to draw it, with these, and then you get another one here. It's kind of weird, wonky. Real
Yeah,
fast.
it's pretty much you get the picture as soon as like, oh yeah, that's the bottom's a hexagon. So I get 168 centimeters squared.
Okay, now the surface area is the lateral area plus the area of the base times 2. So you got to go back to that calculator you've been using, find the area of the base, multiply by 2, and then add it to this other number.
Okay, I get 41.6.
Okay, so what do you do with that number?
I just multiply that. I square that.
No, multiply it,
Oh, multiply by 2.
because there's 2 of them, the bottom and the top.
I get 251.2 centimeters squared.
All right, very good. So now the next problem here is a square pyramid. And again, we might have to draw a couple of views here. So for the square pyramid here, it goes up. It's got 4 triangles, and so for the lateral area, it's these 4 triangles, and it says it has a base edge of 11 and a slant height of 15.
Mhm.
So the lateral area is the 1/2 base times height, 1/2 base times height, but then there's 4 of them.
I get 330 centimeters squared.
Good. Now the surface area is the lateral area plus the area of the base. What is the shape of the base?
The base is a square.
So that's 11 times 11 for that part. So it's this previous number plus 11 times 11.
451 centimeters squared.
Good. All right, this may be the last question. I'll do one more scan here that you wanted us to work on today. I'm actually surprised how much faster these have gone now that we've done them a few times. Okay, so this is a right cone. The party hat.
Okay.
It's got a radius of 6 and a slant height of 13. So the lateral area is pi RL, where L is the slant height.
Mhm.
And you do have to round your answer here. So go ahead and round it to to the ones place. No decimal, just the ones place on this one.
Oh, well, it's 245.
245 what?
Oh,
What are
a
the
centimeter
units?
squared.
Okay, and the surface area is the lateral area plus the base, which is pi r squared. And again, round that to 1 decimal place, please.
$358 centimeters squared.
Perfect. All right, I think that does it for today. Let me just do one more scan. All right, that does it. Well, thank you so much for scheduling, Christopher. I'll send you the notes and the screen recording here shortly, and I'll see you next time.
Okay.
Have a great night. Bye now. Great day.
Bye.
Bye now.